So we're going to be, welcome in this podcast, we're going to be finding the average rate of change over different intervals. All right, so find the average, the table below defines the relationship y equals f of x. Use the table to compute the average rates of change below. So for average rate of change, the x, of course, is your independent variable. The f of x or y is your dependent variable. And average rate of change is always change in y over change in x, which is change in dependent over change in independent. Right, so if a function is not linear, it's very important that when you're calculating average rate of change, you use the interval that it states. So find the average rate of change of f with respect to x. This is just telling you that the value of the function f of x is the dependent, because it's with respect to x, which is the independent. This over here, oops, well, little, not a line there, but this over here is telling you that this is our interval, right? So we have the x values of 0 and 4. So these are our x values, right? Which means that the points are going to be 0, 26, and the other point is 4, 5, right? So when it says over a certain interval, it's just telling you those are the points you use. So average rate of change is going to be 26 minus 5, right? Because it's the change in y over the change in x, right? So it's going to be the 26 first, and the 26 and the 5 in the numerator. So 26 minus 5 divided by 0 minus 4. Right, so it would be 21 divided by negative 4. Right, and that you can just leave it like that, negative 21 fourths. Average rate of change from the function from x equals 2 to x equals 5. Right, so now this time we're using these values here, those 2 points. So our 2 points are going to be 217 and 5, 1. Right, so we have average rate of change is 17 minus 1 divided by, so I started with 17, I have to start with 2. 2 minus 5. So that's going to be 16 divided by negative 3, or negative 16 thirds. Notice they're not the same, right? So a negative 21 fourths does not equal negative 16 thirds, right? So this is nonlinear, because we do not have a consistent rate of change. All right. Any questions on this problem? All right. So we'll be back with more problems later, but it's time for whiteboard practice.